The log of a number is the power to which the base of that number must be raised. If you have a number like 16, 16 in index form can be written as 2 to the power of 4. 2 to the power of 4. 16 is the number, 2 is the base, and 4 is the index. To write this in log format, this will be written as log 16 to base 2 equals to 4. Let's do a quick example regarding what I've just explained now. If you are asked to find x, if log 25 log 25 base 5 equals to x, find x. What you simply do is you take x to 5. This will be written as 5. Remember that 5 is the base. 5 raised to the power of x equals to 25. 5 to power x equals to, index form of 25 is 5 raised to the power of 2. This means that 5 times 5, or you say 5 multiplied by itself 2 times, equals to 25. Now the bases are the same. Whenever the bases are the same, they cancel out. 5 cancels out 5, and you are left with x equals to 2. If log 0.125 to base 2 equals to x, find x. What you do is to take x to the base. The base is 2, and this will be 2 raised to the power of x equals to 0.125. Next is to change 0.125 to a fraction. This will be 2 to the power of x equals to 125 over, if you look at this, 0.125 have 3 decimal places. This means that there are 3 digits after the decimal. So what you write under here, you add 3 zeros because of that. That is 125 over 1000. 5 divided by 125 is 25. 5 divided by 1000 is 200. 5 divided by 25 is 5. 5 divided by 200 is 40. You are left with 5 over 4. 5 into 5 is 1. 5 into 40 is 8. What you have left is 2 to the power of x equals to 1 over 8. When you have a number like this, if you have something like 1 over 2, 1 over 2 can also be written as 2 raised to the power of minus 1. In this case, we have 1 over 8. 2 to to power x equals to 1 over 8. And 1 over 8 can also be written as 8 raised to the power of minus 1. 2 raised to the power of x equals to, the index form of 8 is 2 raised to the power of 3, and you have your minus 1 here. How did we have 2 raised to the power of 3? Remember that 2 times 2 times 2 equals to 8. This means 2 multiplied by itself 3 times gives you 8. 2 to power x equals to 2. 3 times minus 1 is minus 3. We have equal bases. 2 cancels 2. And what you are left with is x equals to minus 3 as your answer. Before I start solving logarithms of numbers with the same base, put it at the back of your mind that log 2 equals to 0.3010 and log 3 equals to 0.4771. In case you have a question in your exams where you need to find the log of 2 or 3, 4-figure tables or calculators are not allowed in this exam, so you should take note of these logs. Let's start with the first example. If you're asked to find log 6, find the log of 6. Log 6 can also be written as log 2 times 3. According to the laws of logarithm, where you have multiplication sign, log 2 is same as log 2 times 3 is same as log 2 plus log 3. Log 2 is 0.3010 and log 3 is 0.4771. When you add these up together, your answer is 0.7781. You are asked to solve log 5 to base 10 plus log 20 to base 10. Recall one of the laws of log. If there is something like log A plus log B, this can also be written as log A times B, provided the bases are the same. So in this case, we have log 5 plus log 20. Log 5 plus log 20 can also be expressed as log 5 times 20 to base 10. Five times 20 is 100 base 10. Index form of 100. 100 can be written as 10 raised to the power of 2 to base 10. According to the laws of log, when you have an index up here, this moves towards the left, and you rewrite this as 2 log 10 to base 10. Also recall the laws of log. If you have something like log 6 base 6 equals to 1, or log 10 to base 10 equals to 1. When the number and the bases are the same, it can be written as 1. It will change to 1. So in this scenario, we have log 10 to base 10, and log 10 to base 10 is 1. 2 times 1 is 2. For every log question that is given to you, always know that the default base is usually 10, except a different base is given in the question, like base 2, base 4, or base 3. But if there are no bases here, just like in this example, know that the default base there is 10, and we will make use of it during the course of our calculation. This question, you have to find log 25 plus log 8 minus log 2. Recall from the last question we solved, if you have log A plus log B, this can also be written as log A times B. Another law of logarithm is if you have log A minus B, this is equals to log A over B. That is log A divided by B. If you've noticed, addition sign changes to multiplication sign, and subtraction changes to division sign. So in this question, this will be log to base 10, the default base, open bracket, 25 plus 8, that is times 8, minus log 2. Remember that minus sign changes to division. This is over 2. You close bracket. 2 divided by 2 is 1. 8 divided by 2 is 4. What you have left is log 25 times 4 to base 10. Twenty-five times 4 is 100 to base 10, and in index form, 100 can also be written as 10 to power 2 base 10. Remember that the index of 2 will move over to this point. This will be written as 2 log 10 to base 10. Log 10 base 10 is same thing as 1, and 2 times 1 is 2. You have to find n. If log 6 to base 3 plus log n to base 3 minus log 5 base 3 equals to 2. Log base 3. Base 3 is the common base here. This will be 6. Since this is plus log n, it will change to times n all over 5. It is all over 5 because we have minus log 5. Close bracket equals to 2. Log base 3, 6 times n is 6n over 5. You close bracket equals to 2. When you get to this level, remember what you did in our very first example. This, you take 2 to 3, and what you have is 3 raised to the power of 2 equals to 6n over 5. 3 raised to the power of 2 equals to 6n over 5. At this point, you simply cross multiply. You cross multiply 6n times 1 is 6n equals to 3 to power 2 times 5. 6n equals to 3 to the power of 2 is 3 times 3, and 3 times 3 is 9 times 5. 6n equals to 45. 6n equals to 45. To make n the subject of formula, this will be n equals to 45 over 6. And when you divide this further, 3 into 6 is 2. 3 into 45 is 15. 15 divided by 2, you have your answer to be 7 whole number 1 over 2. The logs here have different bases. This is base 5 and base 3, but that is not a problem. First of all, you change 4. You are going to change 4 and write it in its index form. Changing 4 to index, 4 can be written as 2 raised to the power of 2. Open bracket 3 over 2, close bracket, plus. The next step is to change 0.04 to fraction. This will be written as log 4 over 0.04 is in 2 decimal places. That means there are 2 digits after the decimal. So that will be 2 zeros, 4 over 100 base 5 plus log. The next thing is to change 81 to index. 81 to index. If you don't know how to do that, you find LCM of 81. 81 divided by 3 is 27. 27 divided by 3 is 9. 9 divided by 3 is 3. And 3 into 3 is 1. So this is 3 times 3 times 3 times 3. 3 raised to the power of 4 is the index form of 81. So this will be written as 3 to the power of 4 to base 3. Next step, here you can the powers will cancel out. 2 cancels 2, and what we have left is 2 raised to the power of 3 plus log. The next step is to cancel, divide this. 4 into 4 is 1. 4 into 100 is 25. You are left with log 1 over 25 to base 5 plus. Remember that when you get to this point, the index 4 comes here. 4 will be right behind the log. This will be 4 log 3 to base 3. 2 to power 3 plus log base 5. 1 over 25 can also be written as 25 raised to the power of minus 1 plus 4 log 3 base 3 is same thing as 1. So this is 4 times 1. 2 raised to the power of 3 plus log 25 raised to the power of minus 1 to base 5 plus 4 times 1. 2 raised to the power of 3 is same as 8 plus log base 5. 25 in index can be written as 5 raised to the power of 2, and here we already have minus 1, so that will be in brackets, plus 4 times 1 is 4. 8 plus log base 5 of 5. 2 times minus 1 is minus 2 plus 4. This is 8 plus, remember what happens when you have an index up here, minus 2 moves over to this point, and this will be 2 log, sorry, this is minus 2 in brackets log 5 to base 5 plus 4. Plus times minus is minus 2. Log 5 to base 5 is 1, and you have plus 4. This will be 8 minus 2 times 1 is minus 2 plus 4. 8 minus 2 is 6 plus 4, and 6 plus 4 is 10, which is your final answer.